So a minor arc is going to be an arc that is less than 180, named with 2 letters. So there are several in the diagram, but specifically the one I'm seeing right now is TU. And then you're just going to want to make sure you also put the arc symbol over top. For a major arc, you're going to need more than 180 and 3 letters. So that could be TWU. Again, there's more than one option, but I'm just going to list one. If you want additional answers, you can check out the PDF answer key. A semicircle is going to be exactly 180 and named with 3 letters, so you can just pick the end points and then one in the middle. So I'm just going to use TUW. Still need an arc symbol. The name of the circle is always the center point, so that would be circle P. The measure of UPV, the angle, so that would be this angle here. Since we know the top of the circle is a semicircle, it's 180. I have 80 and 70, which is 150. If I subtract, I'm left with 30, so this angle here would be 30 degrees. The measure of arc UT, so UT is right here. If the central angle is 80, the arc is also 80. For the circumference, that's 2 pi r. Our radius is 5. 2 times 5 is 10. So this is 10 pi. And then the measure of VWT, so I'm going to do this one in green. So if I start at V, go to W, all the way around to T, I need to add the 70 and then the semicircle. So that's 70 plus 180, which is 250. For 9, it says if a circle has a circumference of 52 pi, what is the length of the radius? So I'm taking the circumference formula and I'm filling in a circumference of 52 pi. To solve for r, I'm going to divide both sides by 2 pi. And when I do that, these pi's cancel, the 2's cancel, these pi's cancel, and 52 divided by 2 is 26. Number 10 is the same process, so I'm filling in my formula. The circumference is 8, which equals 2 pi r. I'm going to divide both sides by 2. That causes these 2's to cancel. 8 divided by 2 is 4. So I have 4 equals pi times radius. I divide both sides by pi, and I get 4 divided by pi for my radius, or you could type it into a calculator. For arc length, remember we're thinking about part of the circumference. So you want to start by finding the circumference. So for this circle, it's 2 pi 8, which is 16 pi. Now, looking at this piece right here, BA, I can see that it's a fourth of the circle, so I really only want a fourth of the circumference, so that's 4 pi. For the next one, again, I'm going to start by finding circumference, which is 40 pi, but then I only want this section over here. Now, I can't really eyeball it this time and just visually see that it's a fourth or whatever, but I do know that it's 216 degrees out of 360, so I can just use that as my fraction, which is 24 pi. For number 13, I'm starting by noticing that this is a radius, and I have another radius here. So those are the same length, which are both x. The length of the hypotenuse is x plus 8. And then since this is a tangent line, I know I have a 90-degree angle, meaning I can do Pythagorean theorem. The setup for this would be x squared plus 10 squared equals x plus 8 squared, x squared plus 100, and then in order to square this, I have to write it out twice and distribute. So I'm going to start with this x. I'm going to distribute, so x times x is x squared, and then x times 8 is 8x, and then 8 times x is 8x, 8 times 8 is 64. I can combine my like terms. And then subtract x squared from both sides. So I get 100 equals 16x plus 64. I can subtract 64 from both sides. 36 equals 16x. And then divide by 16. And then x is 2.25. For the next one, perimeter of ABCD, anytime you have two tangent lines that meet at the same point outside of the circle, the lines are congruent. So therefore, these are both 9. These are both 5. These are both 3. And these are both 8. After that, I can add them all together. So 9 and 9 gets me 18. 5 and 5 is 10, 3 and 3 is 6, 8 and 8 is 16. And add it all together, the perimeter is 50. For this one here, this is a radius. Anywhere you draw in a radius, it's going to be the same length. The goal is to have a right triangle, so I'm going to go ahead and draw a radius in right here, which length would be 20. This chord out here that's labeled 16 is split into two congruent pieces, so I have 8 and 8. And now I have this nice triangle right here that I can do Pythagorean theorem with. So setup would look like x squared plus 8 squared equals 20 squared. X squared plus 64 equals 400. Subtract 64 from both sides. X squared equals 336, and then you take the square root, and that's about 18.3. For this next one, I have a tangent line meeting a radius, which creates a 90-degree angle, and down here, radius, tangent line, 90-degree angle. Since this shape's a quadrilateral, altogether it has to be 360, so inside right now I have 90 plus 90, which is 180, and then I have 52 more degrees, so I have 232. I'm supposed to have 360, so when I subtract, I get 128. For 17, I have an inscribed angle attached to arc QS. So if this angle is 50, the arc is 2 times bigger, which would make it 100. And then here I have a semicircle, which is 180 total. If QS is 100, that means SR has to be 80. For 18, I have a chord meeting a tangent line, which means that this is just a kind of weird type of inscribed angle. So this angle T is half as big as this red arc, making it 100. And then to get S, I know that the whole circle is 360. And over here we have this 200 degrees. So if I take 360 minus 200, I get S, which is 160. For 19, opposite angles of cyclic quadrilaterals add up to be 180. So these two, Y and 65, should add up to be 180. And 75 and x should add up to be 180. So I get 105. For 20, I have lots of different inscribed angles, so I'm going to go ahead and start with y. Y is attached to this arc that is 86, so I take 86 divided by 2. I get 43 for y. Z is this angle attached to this semicircle, making it half of 180, which is 90. And then x, let me erase my diagram real quick. X is this angle, which again is inscribed in this semicircle. Since the semicircle is 180, that makes the angle half as much, so it's 90. This last page is the equation of a circle. So just as a reminder, your equation is x minus h squared plus y minus k squared equals r squared. HK is the center and r is the radius. Since in the equation we have these minus, whatever you're seeing in the equation, we're actually going to be using the opposite sign. So for example, in this first one, visually what I'm seeing is -2, +8. But when I pull the center out of the equation, it's really going to be +2, -8. This right here is r squared. So if I want the radius, I need to take the square root. So I get 4. For the next one, I'm seeing -5 and then nothing. So this is really +5 and then 0. Again, this is r squared. So I need to take the square root. And I'm just going to leave it as square root of 13 for r. Down here, it wants you to fill in the equation. So this is h, this is k, this is r. So it's x minus 5 squared plus y minus -2, which makes it addition squared, equals 7 squared, which is 49. For the next one, it would be x minus 0 squared, and we don't typically write things like that, so I'm just going to make it x squared plus y minus -3, so really that's going to become addition, and then square root of 11 squared. Since the square root and the squared are inverses, they actually just cancel out, leaving me with just 11. If you don't know that, you can just type in your calculator and it will show 11. Down here, this is kind of something we didn't necessarily talk about, but I will go over it here. So this time it's giving you the endpoints of your diameter. So here's truly what you have. You have a point over here, maybe that's 2,5, and then you have a point over here that's -10, -7. So in order to write the equation, we need two things. We need the center, which we don't have. So I'm going to go ahead and start with that. To find the center, I'm going to do midpoint. The midpoint formula is x1 plus x2 divided by 2, and then comma y1 plus y2 divided by 2. So when I fill this in, I'm going to have -10 plus 2 over 2, and then -7 plus 5 over 2. And when I finish this, I get -8 over 2 and -2 over 2. And so I figure out my center is at -4, -1. Then I still need to figure out the radius, and I'm going to do that using the center and 1 point. So I'm going to choose to just use 2,5, and I'm going to go ahead and write right below this. So sorry about that. So now I need to do distance. You're welcome to use Desmos for this. You are going to have a big square root. x2 minus x1 squared plus y2 minus y1 squared. And then you can go ahead and square that in Desmos to get r squared, because sometimes it ends up being a pretty gross number. So when I do that, I'm going to get 72 for my r squared. Once you have all of that information, you can write the equation of the circle. So x minus -4 squared, which makes this plus y minus -1 squared, again makes this plus, equals r squared, which is 72. For 26, you're just identifying the center and the radius. So the center is at 1, 2, and then you can count the radius. So 1, 2, 3, 4, and then you plug it in. X minus 1 squared plus y minus 2 squared equals 4 squared, which is 16. Just as a reminder, you are going to want to memorize that formula, the equation of a circle. You're going to have a really hard time because it's not given, and if you don't know it, you can't do a whole lot. So make sure you're memorizing that. This one is like number 25, but less lengthy. So this time they do give you the center, which is 2, 2. And then they give you a point on the circle, which is 5, 2. So you really are just missing radius, which we get doing distance. So again, you can use Desmos. You're going to do x2 minus x1 squared plus y2 minus y1 squared. And then you're going to want to square that to get r squared. A lot of the time you'll have to square it in Desmos because you'll get like a really nasty decimal. This time I'm just getting 9 for r squared. Then you just take the center and plug it in. So x minus 2 squared plus y minus 2 squared equals r squared, which was 9. For these last two, we're completing the square. So you need to move the constant to the other side. I like to reorder as I do this. So I'm going to put the x's together. So x squared minus 8x, and then leave a space, plus y squared minus 2y, leave a space, equals -10. Then you're going to complete the square by taking this number, dividing it by 2, and squaring it. So -8 divided by 2 is -4. Squared is 16, so that goes here. And anything you add to the left, you have to add to the right. Same thing, I'm going to take this, divide it by 2, square it. -2 divided by 2 is -1. Squared is 1. Anything I add to the left, I add to the right. Then I'm going to factor. So I look for numbers that multiply to be 16 and add to be -8, which is going to be -4. So this is really x minus 4 squared. I repeat that process for my y's. So numbers that multiply to be 1 and add to be -2. That is going to be y minus 1 squared. I'm going to add all of this together. So -10 plus 16 plus 1 is 7. And so that's my equation of the circle. I'm actually not going to do 29. If you check out the answer key, and the process is the exact same, but in the end, I ended up getting a radius that was negative, which isn't possible. So I just wrote a bad question. Sorry about that.